Hey, Maya.
All right, hey, Maya and Jake. This is example 5. This is on 5-2 notes. This is the very last example.
You know that neither one of those are gonna watch them.
I don't care. It's not my job.
We have
We talked about this before. Okay. Example 5. I'm doing my part. I can't do their part. Sorry. But if I don't record it and they come back and they're like, I couldn't do the homework because I didn't have the recording. Well, here you go. Example 5. Now you can't use me as your excuse. Example 5, and then we're going to go to and fill out a review sheet. So not starting 5-3 today yet. We're going to fill in 5-1 and 5-2 like formulas and stuff on a sheet. All right, here we go. Example 5. Okay, this is another mean variance standard deviation, yeah? Okay, so here's the deal. I'm going to go down to example 5 and we're going to talk about what this distribution table would look like. You got to listen. The chapter problem in example 3 involves 460 overtime wins in NFL football, okay? The probability of winning is 0.5, the probability of losing is 0.5, assuming the winning over, we're talking about in relationship to the coin toss.
You can tie. Oh, okay.
Okay, we're talking in relationship to the coin toss. So, regardless of heads or tails, like 50% of the time you're going to get a win, 50% of the time you're going to get a lose based on heads versus tails, okay? So here's the deal. They're basically asking for like, is there an advantage to getting the coin toss, whatever, right? In overtime, there actually is, because a lot of times, I don't know, is it true in the NFL that the first person that scores, okay? So what we're trying to do is we're trying to test that theory. I know. We're trying to test that theory, right? Okay? We know that there is a slight advantage in overtime. Okay, so here's the deal.
It's not.
Out of the 460 teams, let me show you how this breaks down, right? Out of the I'm not going to write the whole table down, but just bear with me, okay? So win, lose. So these are people who get the coin toss. Get the toss, okay? And how many of those people won and how many of those people lose, okay? Whoever gets the coin toss, did they win or did they lose? I could have all 460 of those teams who won the coin toss win the game, which means 0 of them lose, right? I could have 459 win and 1 lose. I could have 458 and 2 lose. And this table goes on forever all the way down, right?
Forever.
Okay, the probability or the P of X of this happening,
Wild.
the probability of all 460 of them winning, you do have a higher chance of them winning, is going to be like 0 plus, yes. Probably still for these two, 0 plus. Then we might get down to like 250 of them winning and, what would that be, 210 of them losing? That might be close to like, I don't know, 8% or something, let's say, right? 8% of the time we're going to have 250 win and 210 lose, okay? So this is kind of how this table breaks down, ready? If we're trying to find an average and we're given the table, like the entire table, if we're trying to find the average, we take this number times this number. Do you remember doing that? We get those numbers and then we add them all together and we do the sum. That's if we have the table, okay? Are you wanting to write down all 460 and make the entire table? No. So here's what we do instead, okay? If we know how many games that are being played, which is 460, and we know the average, or P, which is the percent of win, we can find the average number of people who should win, right? If it's a 50-50 chance of winning and 460 teams are playing, how many should win?
230.
230, right? Find the mean and standard deviation. Okay, so mean. The equation for mean is mu equals. We take our n, which is our total number, times the p, the probability of winning, right? Total number was 460. Probability of winning was 50%. So how many of those 460 teams should win? 230. That is like should make sense, right? Okay.
U equals N.
Are we going to write this on our sheet?
We're totally going to write this on our sheet.
Totally.
Yeah, baby.
Totally. Okay. Now, the variance is n times p times q. So variance is sigma squared.
Sigma?
N times p times q. Okay? N was 460. Okay, what's p?
Oh, that's ligma.
What's p?
know.
What's p?
Or sigma.
0.5. What's q?
0.5.
0.5. This is the variance, okay? This is the variance. 460 times 0.5 times 0.5. What is that? Half of 230, so 115.
Yep.
Yeah.
right.
Is that right?
Yep.
Yes? Okay, then this is the variance.
Square root.
The standard deviation is the square root of that number, the square root of 115. Okay?
STD square
Which
root
is?
of 115.
What's the square root of 115? 10 point something.
12.
No. 10 point something.
Square root of 115.
10.08.
10.7. Perfect.
Damn it.
That is the
10.0
standard
10.7.
deviation.
7.23.
All right, now, given that information, I really don't ever use the variance to find anything other than to get to the standard deviation. You gotta listen. Shh. Okay? B, use the range rule of thumb to find the values separating the number of wins that are significantly low versus significantly high. If I have the average and the standard deviation, how do I find the low numbers and the high numbers? Add standard deviation
Can I get that from your hand?
twice, right? So I add it twice and it gives me this number, and I subtract it twice and it gives me this number. So the average number of games that should be won out of 460 is 230. True. Add 10.7 twice. Plus 10.7. Plus 10.7. That's like 21.4. So that is like 251.4. Check that. Yes. If I subtract 10.7 twice. 2. That's subtracting 21.4, which is 208.6. Perfect. Okay? So, out of the 460 games, out of 460 total games, okay? If we would get
Can you scroll up a
more
little?
than if there you go. I'll move my cursor. Out of the 460 games, if more than 251 of the coin toss winners would actually win the game, we're like, that's maybe the coin
That's what
toss
it
is maybe
says.
actually doing something,
Yeah, that's
right?
what it says.
We said the coin toss does do something in overtime, right? Okay.
Yeah.
And what that is led to believe is because they have had a significantly high number of coin toss winners win the game. Does that make sense? Okay. So if more than 251 win the game, then that's probably going to say like, oh yeah, the coin toss is actually doing something. Now, if less than 208 people win the game, then what's that tell us?
No.
The coin toss is actually ruling not in their favor, right? We don't want the coin toss, which would
is
kind of be
not
weird, like it's not true, right? But if it's less than that, that's the deal, okay? Significantly low would be 208.6, or anything lower than that, significantly high is 251.4 and beyond. Is the result of 252 overtime wins a significantly high number?
Yes.
Yes. The coin toss is like very much giving them an advantage. They very much get an advantage from the coin toss, okay? That is mean variance standard deviation when you have your P's and Q's and stuff, okay?
Hey, do you
Yes,
know
ma'am.
what Exactly's disease is?
No.
It's when your face looks exactly like your butt.
Okay, great.
Hey, turn that cup around.
Tell her what Brett said about it.
No, I'm not going to tell her what Brett said about it.
What did Brett say about
Did
it?
he say something about tatas?
No,
No, he said it was a what did he say? It was a provocative cup?
because it has a zipper on it.
What is
I
provocative?
don't
Yeah,
get it.
that's what I was getting at.
And
Whatever.
then no, Kelsey,
Okay.
I can know what word she
Moving
said.
on.
After that. She goes, I don't know if he thought it looked like, and then she said lace panties. I hate that
Whatever.
so much.
Whatever.
Blech.
No, it looks like something. Like
All
a
right, go to your
jacket
yellow
that,
sheet.
like,
Here you go.
Miley Comacher would
You
wear.
want to make sure.
With,
You
like,
want to make
powder
sure you write these down. Here we go.
Did you tell her happy birthday?
And Huxley's and like 17 other people.
And what's her face?
Jensen.
Jensen.
Jensen down in the preschool. Did you do anything for her birthday? Is she wearing a hat?
She brought food and yeah, she got to wear the crown.
Yes, they brought like a
She brought
big
Rice
thing of-
Krispies and
Kool-Aid
Kool-Aid
jammers.
jammers.
Nice.
And she
Oh
was
man,
wearing
you didn't
her
bring me a Kool-Aid
dress
jammer.
and her braid.
Oh boy. Yeah, she wanted to
Yeah.
look like
What was
Rapunzel.
in
She's
her
not wearing a
braid?
dress.
They're well, it's like a she's not. Well, she wanted flowers in her hair to look like Rapunzel, so they're like little clip-in things.
I went in there, we were doing Snapchat filters, and she's like, "Can you find a princess one?" And the only one I could find was the like tiara.
That probably was.
She's like, "I want to look like," she's like, "I want to look like Rapunzel." I'm like, "I can't find it."
All right, mean
Sorry,
variance
honey,
standard
you're
deviation for the table.
Just kidding. She grew out of that. But her sister, oh my.
Okay, mean variance standard deviation for the probability distribution table. I'm gonna do the heads and tails example. We'll just talk specifically about heads. Specifically about heads and tails. If I have
Is this taking out both boxes?
I know. Rachel. You don't have to be John.
no.
Why are you doing this?
Wait, this is in two
Oh
boxes?
yes, it is taking up 2 boxes. Yeah.
Is everything you've done how it's
How it's supposed to be, yes.
What does that say? Dist table?
Distribution.
you're not very good.
Oh.
Number of heads for 2 tosses.
Probably.
Number of heads for 2 tosses.
Number, heads,
Number of heads for 2 tosses. Shh.
2
Cray, be quiet. You need to be writing this down, child.
Right.
Number of heads for 2 tosses.
Okay.
Okay?
Okay.
Number of heads for 2 tosses.
None.
All right, so let's list them out here. Ready? I could have 2 heads, I could have 1 head, or I could have 0 heads out of my 2 coin tosses, okay? Usually we have a column for tails, but I don't want to confuse you with tails, so like 2, 0,
Yep, we
1, 1,
understand.
Yep.
0, 2, yeah,
Yep,
that's
yep,
how
yep,
that
yep.
will work. But we're talking specifically about heads, so I'm only going to list the heads column, okay? All right, now, I'm going to list my combinations up here. Don't write this down, but this is like I could get a heads heads, or a heads tails, or a tails heads, or a tails tails, right? That is 4 combinations. What is the probability that I get 2 heads exactly? 25%. 1 out of 4, right? Okay, how many of those combinations yield 1 head? 2 out of 4, which is 50%. Okay, 0 would be
0.25.
25%, all right? Does that make sense? This is our table that we have. We're going to find the mean variance standard deviation for this.
You know what I
Mean variance standard deviation. Yeah? Good, good?
Great.
Great. Just great. Okay, what symbol do we use for mean? I'm going to go mean straight across here.
Move. I'm in mute.
The mu. Okay? Mu. I'm going to slide him over because we need a little bit more room. Mu. Okay?
Hey, I can't do that. so
How do you
it's
find
not
the
bad.
average with a table?
Circle it.
How do you find the average with a table?
You, mu equals NP equals 460 times
no.
0.5.
No, wrong.
Sigma,
No, no, because this is for a table. This is not for like the data that we're given. We don't know P and Q here. Well, we do kind of, but we don't. Okay?
look it up on Photomath.
No, no. Photomath is not going to tell
What
you
is
this.
photo math?
You take
equals NP.
no.
Okay,
You take
what's
these
photo
guys
math?
times your probabilities and you sum them all together. The sum
Really?
of all of your x times your p of x's. Shh, write this down. Hush.
I didn't know that was the
Be quiet. Shh. This is your
Okay.
average. Your mean is all the x's times the p of x's. The sum of the x's times the p of x's. These are your x's right here, by the way. Okay?
So 3 times.
All right, so x times p of x. I'm going to do it over here in this column. Okay, x times p of x.
I'm addicted to
I'm trying to X.
What's 2 times 0.25?
I hope you exit this room.
What's 2 times 0.25?
0.5.
0.5.
Yep.
What's 1 times 0.5?
0.25.
0.5. Shh. What's 0 times 0.25?
0.
0. Okay, the sum equals
One.
1.
Rachel said it.
So that means
Genius.
the mean,
Mean is 1.
1.
whoa, the mu
Mean
is 1.
Actually easy.
Yeah, the mean is actually easy. Mu is 1.
Go away.
Yeah?
Hair broke. I'm too fat for it.
Okay?
U equals 1.
Mu equals 1.
Just go.
Okay? All right, pay attention to these. These are very hard. The next one is variance, which is sigma squared. The formula for that is the sum of all of the mu's minus the x's. I shouldn't write the sum like that. Yeah, that's fine, that's fine. I'm gonna put a bracket though. Times p of x. And I'm gonna put a bracket around here.
Oh my god.
Because we gotta do all that junk first. Okay? The sum of all of the
I
mu
can't
minus
even do
x
this
squared
anymore.
times p of x. All right, Here we go. This is the second column. I'm going to do the variance here.
Please scoot over. Please.
I can't scoot over.
Thank you.
Another column?
Well, we'll just put it right here.
No, there's no.
There's no room.
There's no room.
Okay, then find a place to put it. I don't care.
You guys don't have enough room?
Make a new spot for it. I don't care. Whatever.
I'm actually
Like how you do that.
Whatever. Make a spot for it. I don't care. If you're writing it exactly like me, I have room.
Yeah, but you can
I don't like going into
Sure.
the next box.
Sure.
Zachary.
Sure. Okay. All right. The first one. Ready? I take mu minus x. Okay, what's mu?
The,
One.
1 minus what's x?
2.
2. I square that and I take it times what's p of x?
I need to write sigma.
0.25.
0.25. Okay? That's that. Okay?
Sorry.
1 minus 2 squared times 0.25. Okay? That is
0.25.
0.25.
my pencil.
Stop it.
Okay, the second one.
See, you
Mu is still 1 minus 1 squared
0.
times
0.5.
0.5.
0.
Yep, it's 0 times 0.25, which is still 0. Okay? The third one.
Minus 0.
1 minus, whoa,
1 minus 0 squared is 0
times
times 0.25.
0.25 again is,
0.0.
no, no,
Oh, no, it's
0.25
1.
again.
It's 1. Because 0 squared is 1, so that means 1 times 0.25 is 0.25.
0.25. Okay, now I sum all of those, and that is 0.5. And what is that number?
What is it, Kelsey?
The variance.
That's the variance.
Variance.
No way.
Okay, so this is the mean. If you need to write that down, I don't care how you want to write it. Okay, the variance is my sigma squared, which is 0.5. Okay,
I'm gonna have to take the square root of that.
then I want just sigma, which is the standard deviation. That's the square root of 0.5, which is just, what's the square root of 0.5? 0.707. Check me,
Probably. You're probably right.
I believe. These are my 3 values.
I believe.
Okay, those are my 3 values.
That's your standard deviation?
That's my standard deviation. So,
Gee, that would've been
standard deviation.
You know,
Okay, these are the stop. These are the symbols that you use. Okay, that's my information. That is if I'm given the table. Yeah?
Yeah.
If I'm given the table. All right? Good,
Now
good?
you're not.
great.
Okay,
Wait,
I'll zoom back in.
You just phoned that.
so standard deviation is just that?
Why won't that go away? There we go. Now it's gone.
Ow.
Standard deviation is just the square root of the variance. So after you find the variance, it's easy.
Okay.
Okay, good? Happy with that? Yeah?
How many of these do we have?
Okay, we gotta go through 5.2 now. Stuff that we learned yesterday. Okay, let me see how I wrote it because I wrote it nice. All
I
right.
think that is nice. That's a
Finding
mess. I don't even get it.
Marcus.
the probability.
Is that in 2 boxes?
Finding Nemo.
Are you using 2 boxes for this?
Yes,
Why?
because we have to do.
Sorry about that.
I don't even get it.
Okay, binomial probability distribution.
Girl, why do you have it written down already?
Because this is last year's. And it worked out really nice last year, so I want to make sure I read it the same.
Yeah. So why don't we just use that?
Did Caleb pass the class?
I don't know.
He graduated, so.
This is hurting my head.
You don't
Okay.
have to pass it.
P of x
No, I wrote it.
equals. What's the formula?
You bet.
What's the formula?
Is it this?
Starts with NCR. Go. Next.
Q,
I'm
P
sorry.
to the
Can you go
R.
over?
Q to the N minus R.
There you
Can
go.
you go over?
But
That's what you need.
Finding
Okay.
probability.
Uh-huh.
and
Are we gonna have to fit more in this box? Can I write it sideways?
Go for it. No, we gotta put something down here.
Wait.
Okay?
We did this.
Do we need to write down what N and R and P and Q are?
No.
Do you understand what those are? Yes? Okay, let's write it down.
Probably.
N is, what is N?
Total number of outcomes.
Total number.
Worst time, not the worst.
R is the
selected number of success.
I'm gonna say number choosing. Okay, P and Q.
Probability of success.
Probability of success. Q is
What's R? Hold on.
Probability fail.
probability fail. Is the number that we're choosing. Like, I want to know exactly 3 out of 5 trees killed. N is 5, R is 3. I don't know. Okay?
Yeah.
All right, last thing. This is the mean, the variance, and the standard deviation. Okay? Which we did calculate up above, but I'm going to show you the difference between the two. Ready? The difference between the two. The bottom one is easier, the top one is not. To find the average, you take N times P. To find the variance, you take N times P times Q. To find the standard deviation, you take the square root of this number, whatever that is, right? Okay, the square root of NPQ, if you want to write that in there. Okay? Now, the difference here is what you're given to begin with. If you are only given the table, you do not know what N and P and Q are, correct?
Yeah, but.
Okay? If you know, you could from the table, maybe, right? If you do not know, if you do know N and P and Q, you have an easier time, right? It's a little bit easier for you. So it just depends on what you're given to how you find the average and the standard deviation and the mean, right? Or the mean, variance, standard deviation, okay? All right, so let's do an example. Here's your example. I'm gonna use the same example as was before.
I want to kill my.
Okay, all right, here you go.
Self.
Oh.
Mood.
The probability of passing a test.
Mood.
Oh.
90% of the people pass the test. Okay, it means 10% don't, right? Out of, there's 14 students in here.
I didn't pass on.
A drug test?
Out of 14 students,
Oh, drug test?
I want to find the probability that exactly, let's say exactly 4 pass. Okay, now let's just think about this, okay? If 90% of the students are passing,
Yep.
out of 14 students, what's the chances that only 4 of them are going to actually
Really
pass?
low.
Really low.
Probably low. You're going to have more than that, right? Maybe like 11 or 12, right? Or even 13, right? Because 90% of 14 is going to be like 12 or 13. Probably 13 point something, right? Okay? So probability of exactly 4 pass is going to be low. Let's calculate this, okay? So let's label N and P and Q and R from this example. What's N?
14.
14. What's R?
4.
4. What's P?
0.9.
0.9. What's Q? 0.1. We're calculating the probability that exactly 4 of them are passing.
You just plug it all into your computer and you get
14, C4, 0.9, and 0.1.
Shove my pencil down your
Okay, now my exponents on my 0.9 and my 0.1. How many am I wanting to pass?
4.
4. That means how many of them are failing? 10. Those add up together to be the total, right? 4 passing, 10 failing, okay? Plug that into your calculator, see what you get. It's going to be a low number, like 0.000 something, probably.
Hey, Tino.
What?
Couple people plug that in for me, please. Would ya?
What are you asking? The
It's like
answer is yes.
0.000000066.
You failed?
How many zeros?
1, 2, 3, 4, 5, 6, 7.
1, 2, 3, 4, 5, 6, 7, 6, 6.
Grace.
Okay, we said it was going to be low, right? We said it was going to be a low probability. Because if 90% are passing, the chances that only 4 pass, 7. 7 zeros and a 6, 6. Okay?
Wow, that's a small percentage.
All right, now let's find out what's the average number of people that pass. So let's find the mu out of that. Okay, let's find the average. Okay? If 14 students and 90% pass, what's the average number of passers out of 10 or out of 14? What is that number? 12.6. We would have 12.6 passers in the class, right? Okay?
14.
This is the reason why.
0.1.
Okay? This is the reason why this number is so low of a probability. 14 is a lot different than only 4 passing. The discrepancy between those two, the wider the gap, the smaller the percentage is, right? That's why we got such a low percentage. All right.
Wait, what does mu?
The mu is the average, the
Average
mean,
what?
the mean number of people that pass,
Oh,
right?
Okay.
Okay,
So
so
mu is
I'll write that in here.
6.
The mean number of passing people.
The mean math teacher says mu.
Okay.
Shut up, right?
The mean number of passing people. Does that make sense? If 14 people in the group and 90% pass, that means about 12.6 people will pass. So 12 to 13 people will pass. All right, who's the one? Or the two?
Miles.
I got 3 boys in here. We'll pick on Craig.
I've never
There
done
you
drugs. I
go.
was gonna say, what are you pointing at
Oh
me
yeah,
for?
I've never done drugs.
I could, yeah, okay.
You
I
could
actually
fail
have
me,
never
but-
done
Whatever,
drugs.
I could fail you. All right. The variance
Hit me
It's
up.
1.26.
is NPQ, so 14 times 0.9 times 0.1.
Let's do it.
What?
1.26.
1.26 for a variance?
Yeah.
This is the variance.
1.12.
Okay, the standard deviation, the square root of 1.26, which is 1.12.
Yep.
Okay, so this is the standard deviation.
If you slow down.
1.16.
1.26 and 1.12 is the standard deviation.
I did not.
Okay, now, don't write this down yet. Now, don't write this down at all.
Standard deviation.
Don't write this down, but follow along. Here you go, ready?
Yep.
12.6 is the middle. Okay, if I add the standard deviation twice, that would be like adding 2.24, right? Or subtracting 2.24, right? That would be like this guy twice, okay?
Yep.
So, adding 2.24 is 14.84. So if everybody passes, if all 14 of them pass, is that like gonna be like, holy cow, I can't believe everybody passed?
No.
No, right? But how many people would have to fail in order for me to be like, whoa, something happened?
Something like
2
10
point-
point.
Like 10.36.
Yeah.
If 10 people fail out of 14,
Fail, you mean pass?
like
Yeah.
pass, I mean, if
Yeah.
only 10 people pass and 4 people fail,
Then
that's
there's a
gonna be
problem
like,
with you.
something's going on. Maybe I didn't teach them well enough, or maybe the test was too hard, or whatever, right? Okay, this is how this is working, yeah? Good?
Yep.
Okay, perfect.
No, don't. I'm not done.
You don't have to write that bottom part down, Emma. That bar, don't write that bottom.
Two.
You can, I don't care. Whatever.
We're done? Can I go to the restroom?
Right now.
Oh, we're ready.